Thank you for joining us here on Vital for Colorado Radio. I am Jon Ekstrom, your on-air producer, and joining me is our host and chairman and CEO of Vital for Colorado, Peter Moore.
Well, thanks a lot. That's a mouthful, I guess.
Also an attorney at Robinson, Wathurst, and O'Dorsio.
Okay, well, thanks for
the
getting
king of sting. Float like a butterfly, sting like a bee, Peter Moore.
Well, thank you very much. I guess you had a good New Year, it sounds like.
I'm doing just fine.
We've had about just over 70 hours of the show, and it's twice a month, and it's something I look forward to greatly. So thank you very much, John. It's been a very good ride. And Michael, thanks for joining us. We have Michael Webb, who's the CEO of Petrol Alchemy. And alchemy is a fascinating old world. I guess when I was a kid, I believed that you could turn lead into gold, and that's always been the dream. But you've taken it a different direction, I think. Why don't you tell us about Petrol Alchemy and a little bit about your background?
Good. The petrol is related to fuels. And like you said, in the medieval times, right, the alchemists are the ones that actually define a lot of what chemical engineering is about. In their case, they had this transformation of a base metal going to gold. Mm-hmm. And I was just reading here not too long ago, they've actually achieved something like that about 2 weeks ago.
Wow.
And actually moving up the ranks of high-value materials.
Is the cost greater than the cost of gold?
I didn't read that part, but I have a feeling it's fairly expensive.
Yeah, price of gold won't be threatened anytime soon.
One suspect, yeah.
What's your background?
My background, I have a lot of leadership background.
Yeah.
My undergraduate's in chemical engineering. And one of the things that I did is I never practiced as a chemical engineer.
Really? Why not?
It's just as I started going through different corporations, I think my style was a lot more open. The discipline of engineering was still there, but kind of my telltales of the places that I've been have been far more about leadership and, driving new business concepts.
That's interesting because I know as a liberal arts graduate, I knew I'm not going to go somewhere and necessarily practice liberal arts. But it's funny to me because I've worked with a number of folks in the corporate environment, working on public relations and public speaking training and getting ready to talk to media. And I always ask them, I say, when was the last time you actually did any chemical engineering? I worked with a chemical engineer. And he said, probably about 20 years.
Yeah.
So eventually you're going to move out of that anyway. It's just funny that you never started.
No, I spent most of my career in the automotive areas, and originally with General Motors and then with GM Toyota joint venture, and then out of that with the Toyota Group itself.
Oh, wow.
So my background was, even though I was technical with the Toyota Group, they had plans to build manufacturing operations here. But for them, it was a very systematic approach that they took. And what's good about it is if you can take those fundamentals and reapply them. Mm-hmm. For instance, I did a lot of work. I used to be an officer at U.S. West.
Oh, wow.
Yeah, at one point in time. And one of the things that we did is we worked with the 3M company on a lot of technical equipment for our technicians, field technicians. And so we did a joint venture with them. And so reapplying a lot of what I learned in manufacturing to actually visit where they were producing the manufacturing equipment allowed me to go out and audit.
Oh, that's interesting.
Yeah, and they were really surprised because typically if you were a senior person at a belt company, you weren't out in their manufacturing area.
Probably not.
Yeah. So yeah, it worked out very, very well. And actually, when I left U.S. West, one of the things that happened is the 3M company approached me about doing some joint work, which we did do. And one of the things that we focused on was innovation. And as you know, 3M brands, 3M innovation. And if you know much about how 3M works, I mean, that is their DNA.
Right.
Their corporate DNA. And so everything that is in regards to the infrastructure of how people focus their time, how they're rewarded, is all about innovation. And one of the joint technology ventures that we did with 3M is we created new software that would allow us to actually, with technology, come up with innovations. And so we developed the world's first connection engine called Relevance Logic. And Relevance Logic is very important because instead of a vertical search, something like Google, this is a horizontal. And so it connects every single word with every other word. So think of a Google search, which is typically as good as the questions you ask.
Right.
And so if you don't know what it is, it's very hard to find something. And we would take a lot of the top 200 instances of Google, and we'd connect every single word to every other word.
But it's also, with the vertical approach, it's also easy to supply the right answer, and the right answer is the person who advertises. As long as it's in the ballpark of what you think that you've asked, it looks like the right answer. So there's kind of an economic motivation, I think, behind that, and that's running the world right now.
Yeah, it's prioritized ratings.
Right.
And guess what? Price for what you receive, that's part of that.
Right.
Ours is
but it's not necessarily the answer.
Right.
Well, it's funny talking about innovation in a very real way, which I think is a nice setup and sort of part and parcel to what we talk about on this show all the time, Peter. We've talked about advancements in technology in the oil field, and usually we're focusing upstream. You know, we're spending a lot of time talking about capturing methane on site or, you know, advancements in hydraulic fracturing techniques, things like that. But what we're talking about today is a little bit more downstream.
Yeah, a real theme of Volta for Colorado, and I was telling you a little bit about it before the show, is just to talk about the innovations. And it's my observation, especially since the economic downturn in 2014, in so many different fields, there's been great innovation. And it's relevant because it changes the safety dynamics, it changes the cost dynamics, it changes almost everything. And then quite often I'm frustrated by people who want to rail against this or that, and they don't know anything about much of what they're talking about, and usually looking at the world in a static way. They've ground down to some number at some point in the past. And they said, based upon that number, I can make this political argument, it'd be great. The problem is, with innovation, things change. And your technology, which I would like to explain, will probably get away from the details of the long carbon molecules, which I might be a little bit esoteric, but almost everything else is incredible in terms of making things cheaper, more available, make the country safer, improve, actually just make the country safer because of
the energy security aspect.
Right. And then also getting into like a really big issue such as reducing carbon from boats and ships. So I think your technology touches all of those fields, but why don't you tell us what your technology is?
And how you got there, because coming out of this background, you know, talking about working in the auto industry and then, you know, working for 3M and innovation, how did you move into, you know, more the fuel side?
Actually, we worked with 3M. I didn't work for 3M,
right.
Just for clarification.
Right, my mistake.
One of the issues that you'll find out with innovation, usually it happens from an outsider, somebody that's not invested into what's there. So therefore, your degrees of freedom about thinking of new concepts actually is unencumbered. And so when we started to look at how, for instance, oil is processed, a lot of different things happened. If you know much about the refining process, cracking, that's been around for over 80 years.
Yeah, very old technology, and I don't think we've permitted a new refinery in the country since like 1973.
I think somewhere in the 70s, you're absolutely right. And it actually plays out as we talk later about why this process that we use, that we call reformulation, different from refining. Refining as a term usually means taking impurities out, whether you're refining metals, anything else. Reformulation means that we rearrange the chemistry by adding new chemistry in order to achieve an output that's not a refining process. So ours is much more about reformulation. And the basic premise that we have in reformulation is around how do we re-elongate long-chain carbon molecules, as you were talking about. So for us, we looked at it in terms of organic chemistry. And what could we do?
And everyone's favorite subject in college, by the way. That's when you are of a certain age, you'll hear people just complain endlessly about organic chemistry. Yet, if you can master that, you can do remarkable things.
So, fortunately, they didn't offer that in my college.
And I never advanced far enough. Science, not a strong suit of mine, which is why I host this show.
Okay. Well, I'll just give you a kind of compare and contrast. If you take a look at basic refinery, some of the parameters, and these are general because each one is different.
Of course.
But approximately 800 degrees Fahrenheit to process, and approximately 1,400 pounds per square inch pressurization.
Yikes.
In order to do that. So, as you know, anytime you mix volatile fuels with high pressure and high temperature, what could go wrong?
Right.
Yeah.
It's a bit of a high wire act.
It really is. And like you said, a lot of this is older technologies. You know, you're thinking about refineries that are 50 years old now.
Right.
You know, so they try to do a lot of upkeep and maintenance.
Actually, all of them are at least 50 years old, and most of them are older.
Yeah.
And what's remarkable is if you think about that in those terms, most people don't even know that. But if you think about it, they have done remarkable work in keeping up with our ever-growing demand for fuels. It's almost a miracle when you consider it from that angle.
Yeah, absolutely. And so one of the things we looked at is understanding kind of the outputs of a refinery. And I'll ask you to. When you think about outputs of a refinery, not necessarily fuels, what do you think of?
Carbon monoxide, number one.
Other VOCs?
Yep.
I couldn't name them off the top of my head. But a lot of CO2, a lot of VOCs. I imagine
I guess carbon monoxide, carbon dioxide,
sulfur compounds.
Sulfur compounds.
There's got to be some solid waste, perhaps some liquid waste.
And it turns into gases like methane, and that's one of the more dangerous gases for the atmosphere.
Right.
So it's good to control methane.
Right, which is why refineries are so tightly regulated as well, because you generate these products, you have to control them or mitigate them or capture them. There's a lot that goes into that, but I'm interested to see where you're going with this.
Well, if you had a clean sheet of paper and you said, what could we do? If we knew what the output was going to be, which is high-value fuels, what else could we do other than following the refinery methodology? You know, refineries do spectacular work because they move such volumes of fuel. What we wanted to do, and to give you the contrast to that, our process, the reformulation process, is basically chemical processing. But it was the patents that we created around the mixtures of fuel that were so different. And with the chemistry that we use, the combination goes like this. Our standard heat-related processing is 230 degrees Fahrenheit.
Compared to 800?
Compared to 800. So what do you think happens between 230 and 800?
You create a lot of gases.
And guess
You
what?
convert a lot of liquids to gases.
We certainly do. And the other part is, what do you, and you probably know this from cooking, if you have something that you want to be warmed up versus something on a rolling boil, do you think it costs more energy to raise the temperature of a liquid 4 times?
Right.
Yeah,
certainly.
Yeah, you consume tremendous amounts.
That's fairly intuitive.
And the same thing with pressurization.
Okay.
The pressurization is very expensive to keep. And so for us, we don't pressurize.
Oh.
Yeah. So it's very different in terms of safety, much safer than what's typically done. And our unique formula of chemistry allows us to produce, and this is one of the really great things, the inputs can be different. For instance, we can use used motor oil.
As opposed to like light sweet crude?
Exactly.
Okay.
And true, there isn't that much UMO, the used motor oil. But what's good about it is the sulfur has typically been depleted. So for us to convert that into a higher value fuel like Jet A or JP8 jet fuel is something we can do. And what's good about our process outputs is instead of, like you were saying, the methanes, the sulfur compounds, all of those things, we emanate pure oxygen.
Oh, wow.
And oxygen is good. It's a scavenger. But I'm just saying during a 6 to 8 hour process, we emit as much oxygen as 40-acre treed lot.
Wow.
So there's a lot of great base oxygen available.
Are there any environmental regulations with regard to the emission of oxygen?
There is.
Yeah.
Really?
Yeah.
Yeah.
Wow.
Which, I guess EPA or what?
Well, part of what it is that it's very flammable.
Right.
Oh, sure, yeah. Yeah, I mean, space shuttle fuel is typically liquid O2 in a lot of ways. So, yeah, you're right. That's interesting.
Well, oxygen is very volatile. It combines with almost any other. It combines almost with any other molecule and becomes a fuel.
Well, Peter, this was like 4 or 5 shows ago. We were debating about whether or not oxygen was good or not, which it's all contextual. And so, I mean, in terms of emissions, emitting oxygen into the atmosphere, I would say that's not a bad thing. Probably good that it's highly regulated. But, I mean, compared to some of the other emissions that you could have, obviously.
Well, if you just mix it with hydrogen, I think you're okay.
Yeah. Well, most of ours is produced. We have an ozonation process that basically enriches the fuel. And so that's where the oxygen comes from.
Right.
How long has it taken you to develop this process? And you, I imagine, along with a whole team of others. How long have you been working on this?
7 years.
7 years.
7 years.
And when you started, let me reverse this question. Where you are now, did you picture being here when you started? Or has the journey sort of twisted and turned in a way that you didn't expect?
It always goes in ways that you could never expect. I'll give you, for instance, one of the catalysts that we use is ethyl ammonium nitrate.
Okay.
And EAN is not legal to possess in processing quantities. And that happened in 2 ways. Number one, EAN is used in the manufacture of methamphetamine.
Oh.
So if you ever hear these labs blowing up,
right,
it's because they're trying to make their own ethyl ammonium nitrate, which can be very explosive.
Yeah, very volatile.
Very volatile. And we don't use that specific form of EAN. The other piece is that it can act as an accelerant. And if you remember Mura, Oklahoma, what happened there, and they ignited, 5,000 pounds of fertilizer, potassium nitrate, and they used the EAN as the accelerant to start that. So needless to say, that's a tightly controlled substance.
I think West Texas was almost taken off the map because an entire plant blew up.
Right.
Yeah. So we had to find out which agency in the federal agencies were responsible for us to be able to get our accreditation.
Right. Here's what we're doing. Here's how. Here's why. Come oversee it. right?
I assume it's ATF or something like that.
That's one of our assumptions, too. It actually turned out to be Department of Homeland Security, but underneath the Department of Homeland Security, it was the DEA, the Drug Enforcement Agency.
Because methamphetamine.
Because of the methamphetamine.
Yeah.
Wow.
Yeah.
And
Bombs or drugs? Which one do you regulate most?
This is quite the exciting show. I did not expect we'd be talking bombs, drugs, the ATF, the DEA. Wow.
But
it's a pleasure having you here, Michael.
I'll tell you what, I will put in a plug here, is that the 2 ATF agents that visited us, when we actually found them through our congressperson, they were 2 of the most professional people I have ever worked with.
That's terrific.
Yeah, in fact, it was stunning. I mean, the fact that they were so uber professional and they were in the DEA, which, I'm thinking Serpico and all these, which wasn't the
DEA
case.
Doesn't exactly have a sterling reputation when it comes to Hollywood's portrayal of it.
Exactly.
So, which can color all of our perceptions in that
So
way.
the net result, you get a permit or license as long as you follow certain protocols?
Exactly.
Yeah.
And, they want to account for every milliliter of what's made, how it's used. They want 24/7 surveillance of the processing. It's all the right things. It's all the right things.
Sure. So in that 7 years, I know you're in a number of phases when it comes to this company.
Yes.
So take us through. We have a little bit of time left in this segment. What was phase 1 and where are we now?
Right now, we're in phase 3 of 4 phases.
Okay.
And the first phase was more about actually setting up to validate the process.
Sure. Understand the science, right?
Exactly.
Do some hypothesis testing.
And the other part, too, is that we have different patents that we had granted to us. And as you know, we're an intellectual property-based business.
Certainly.
And so we had to ring fence all of the IP and all of the addendums to make sure no one else could squeeze in between the cracks.
Sure.
And that took us a while to do as well. And then the next step that you have to look at is the scale up. And in our process, we use 2 different methods for that. One is a batch processing, and we typically use that for a mobile processing unit. And the mobile processing units, to give you an idea, compared to a refinery, we can have everything outside of the input and the output side, all the processing done on the 40-foot trailer.
On a 40-foot trailer?
40-foot trailer.
Well, if you think about when you picture a refinery, because where we record this today, we are not far from one.
Right.
You think about the footprint of that. It's enormous. I mean, it's gigantic. And so the idea of doing this on a 40-foot trailer is my brain is going to just melt right out of my head.
Yeah. So what it means is, even though we do something very different, the real strategic advantage we have is logistics.
Certainly.
So at this point in time, we've partnered with one of the largest companies in the world, and they want to use our process, in this case, the used motor oil converting directly into, number 2 diesel, something like that, is a mining operation.
Okay.
And the logistics behind that is mining, by definition, is in a remote location.
Absolutely.
So it's very expensive to move fuels in. It's very expensive to use, take the used motor oil out. What if you had a process that could combine with their used motor oil and producing some offset for their fuel systems?
Let's talk about more of that in the next segment. Peter Moore, the master of disaster, king of sting, chairman and CEO of Vital. Please give us the plug for Vital.
Vital for Colorado is a coalition of 88,000 Colorado citizens, over 1,000 businesses, run by a 15-person board of directors. We try to be the voice of business for oil and gas national policy. www spelled out vitalforcolorado.com.
Terrific. We'll be back with more in the next segment. Michael Webb, Peter Moore, stay with us. We'll be back shortly. Thank you for staying with us here on Vital for Colorado Radio. I'm your on-air producer, Jon Ekstrom. With me, as always, the one and only Peter Moore, Chairman and CEO of Vital from Colorado.
Well, thank you very much. Our guest today, we're very happy to have Michael Webb as the CEO of Petrol Alchemy. And we've talked for a little over 20 minutes about the process, but let's get into the details a little bit, because this idea of changing almost any other kind of fuel and adding catalyst to it and changing the chemistry of it and to result in the outcome that you designed for without heat pressure and then your output is oxygen.
Well, not as much heat.
Not as much heat, but not much more than ambient temperature in the Sahara on a hot day, I suppose. What is the process?
Well, I wish I would have canned what you just said, because that was it in a nutshell. What we can do... Well,
that's what I got from your materials.
They were good materials.
Yes, sir.
Clearly. And Peter does his homework, which is
he does.
Expect from a lawyer.
Yep. We can take different inputs, for instance, used motor oil or crude motor oil. The difference between the two is that when we process crude motor oil, we also have different materials that we can produce other than the high-value fuels like jet fuel. We can produce the aromatics, and the aromatics, think of it as a gas-like material, but as you use commercial gasoline, it's a blend, and we don't do the blending. But one of the good values that happens is the typical aromatics that we do take off are about 130 octane.
Right.
Wow.
So, yeah, put some of that in your motorcycle. But one of the things that happens is that's about 26% of the output. So if you look at the percentage effectiveness of the output, we're in the mid to upper 90s. So we don't flare gas, we don't do any of those kinds of issues. So what we produce is truly the high-value fuels.
Well, you don't flare gas because you don't have the pressures, and you don't have the problems in gas created inadvertently because of the refinery process. You sort of get to go right away.
Absolutely. And we've also found out another use for our process, and we're working with a local refinery group here in Colorado. And what they do is they make a clean number 2 diesel.
Right.
And I mean, it's outstanding. The manufacturers like Cummins, Caterpillar, those people love it because it is so clean burning. It elongates how long the engine lasts. It really is something good. The problem is they're about a third more expensive than the market brands.
Right.
But they are clean. And one of the things that we're doing with them that we could do with other refineries is we can take their output as is, and in their case, it's truly a green output, and then we re-elongate what they have into jet fuel.
Right.
Wow.
So the margins are much higher for jet fuel than they are for number 2 diesel.
Sure.
So it allows something like a green product to become very viable in the commercial marketplace.
What's the cost differential between your jet fuel and market jet fuel? Is it about the same or a little bit more?
It's quite a bit less.
Okay.
Quite a bit less.
So I'm putting you on the spot here, and you may or may not know this, but I'm just framing this in terms of, average consumer experience. I was just on a plane over this last weekend, and what is the average fuel cost for your typical plane going from Denver to Los Angeles? How much are they spending in jet fuel on just one trip? Do you have any idea?
Well, I do. I used to work at Boeing.
Oh, great. Perfect.
But a lot of it is based around the factors. Is it a 2-engine jet? Is it a 4-engine jet? Is it 600 people? Is it 130 people? There's a lot of factors that are in that. But, most people don't even realize that the fuel tanks are in the wings.
Oh.
So it's a stabilizing factor. But I would say, again, time, distance, equipment, but it's very profuse.
Okay. Could you put a dollar amount on it, or would you hesitate to do that?
I would hesitate to do it because we went to one of the largest airline companies, and they had a fuel supplier symposium. Mm-hmm. And one of the things that I took away from that is that they basically said, I will buy from you, Paul, if you're 1/10 of a cent lower.
Right.
Of course, you meet all the quality standards.
Sure.
Than you, John. But you know what, John? If you're 1/10 lower later than what Paul is, we'll switch back to you.
Okay.
It's called customer loyalty, the new customer loyalty.
Well, it's a commodity.
Yeah.
I used to live next door to an executive chef of a large upscale chain, and very similar what you're describing to me with his suppliers.
Exactly. So when you deal with commodities, you see different airline carriers. One in particular has their own refinery.
Oh.
And so when, we asked this group about the refinery, what was the real reason they bought it? It's not to be competitive with others, but in case there's ever a stoppage, there's a political, geographical event that happens.
Sure, geopolitical unrest.
Exactly. They wanted to make sure that they could always have access to fuel.
Interesting.
Are they competitive? I'm sure they're probably, somewhat competitive, but that was not their strategy.
Wow.
So tell us about chips and IMO 2020, because I gather you can also design your output to meet the new sulfur standards imposed, or not really imposed, but I don't know if the right word is imposed or suggested. It's somewhere in between, I suppose.
Well, it's actually imposed. And IMO 2020 stands for International Maritime Organization, which is a United Nations kind of initiative. And what they found out is with all of these oceanic carriers, all the super tankers, etc., the basic rule is if it ignites, we'll use it for fuel. So think of bunker, sub-bunker fuel, and what the amounts that are out there. They'll typically quote about 3.5% sulfur is what they use today. In 2020, which is
around the corner here.
11 months from now, we switched to 0.5% sulfur maximum.
And how many U.S. refineries, for example, meet that standard?
There's actually quite a few that could. The problem of it is there are X amount of capacity issues with refineries. One of the articles I read said that they're predicting, as an output of this, a potential cost increase of $200 to $300 per barrel.
Oh, my.
Yeah, not because the access to the oil is a problem. The access to the refined at that level, the 0.5
Is it
sulfur.
per barrel or, I guess, per container? Is it based on a barrel of oil? A barrel of oil?
A barrel of oil, yeah.
So what
I can't imagine that.
Oh, no, me neither.
I mean, what is it today? It's like 50, 60 bucks a barrel?
Yeah.
It all depends what type you buy, Brent, West Texas Intermediate, whatever, light crude or whatever. But just say 60 bucks is close.
And that would go up by $200 to $300 a barrel.
Up to a price of about $200 to $300.
Okay.
My own view is I don't believe that's going to happen. But if you think about all of the little things we buy, like the pen that you have, and you buy that on eBay and it's coming from China, how much do you think that costs to ship? It's nothing.
Right.
It's nothing. All of that changes radically. And it's not just the U.S., it's every country that's involved.
Wow.
Yeah.
So, Peter, you brought up IMO 2020.
And by the way, the reason I said I don't know if it's suggested or imposed is that I question the enforcement mechanism of any UN of any UN group.
Certainly.
And I don't know what it is. I don't think anybody knows what it is. But there will be many, many countries. And fortunately, one of the larger shippers, Maersk, I imagine, for political reasons, will want to adopt it because they want to be able to say and distinguish that we meet the standard in IMO 2020. So I think it will happen eventually by market forces. But I'm not sure it will be imposed by any international government agency because there really is none.
There's no enforcement arm for it.
Well, yeah, not for this kind of thing.
Right.
For certain kinds of military activities, there's a great enforcement arm, but not this one.
Well, the reason why it's important for our process is that we were approached about 2.5 years ago by several of the ports.
Right.
And they were looking ahead to 2020. And so they pre-ordered a lot of fuels from us to try our fuels, and that if that's successful, they actually want to license our technology to be able to put a fixed processing unit right there at the ports.
Oh, yeah.
And can a fixed processing unit, I guess, produce enough fuel of the low sulfur content to meet a port's needs? That's a lot of fuel.
It's a lot of fuel. The good thing is, as I told you before, I worked at Toyota for
Right.
a long time. The one thing you understand about Toyota is about modularity, whether they do it in their manufacturing operations. What we can do, and this is one of the key features of our process, is if you need 100 million gallons per day, we can design a fixed processing unit for that to happen, or you could order 250 million
Right.
processes or 425s, or
Sure.
it's like making change. The reason why that's so important is that you're never shut down. Like when we switch over between winter fuel and summer fuel, and we do a lot of refurbishment, repairs, you'll notice there's a spike in the gas price. And part of it is because the refineries aren't processing when they do that.
Right.
For ours, it's real easy that if your production schedule goes up, you can add another modular piece of equipment. If it goes down, you take that offline without shutting down the entire capacity.
From what you sent to me, I understand that IMO 2020 has no phase-in period. It's just a date.
Drop-dead date.
And it's drop-dead date. Date's coming up soon. In reality, there's going to be a phase-in because some people will respond, some people won't. But let's just take a hypothetical. Let's say it's 10 years in the future. Let's say all the shipping in the world meets IMO 2020 standards at 0.5% sulfur content for the fuel. Has somebody done a study as what that impact will be on greenhouse gases?
I'm sure they have. This was actually developed 5-7 years ago.
Right.
The issue is they studied more of the impacts if they don't.
Right.
So they know with the total amount of the environmental pollution that you were alluding to earlier, that actually the Maritime will produce more environmental hazards than all of the automobiles.
Well, that's what I was getting to, is that I generally knew that. I knew that the greenhouse gases from ships, and there's an incredible amount of shipping that's going on. It's far greater than automobiles. Nobody talks about it.
Oh, yeah.
Nobody talks about many things. They don't talk about port security. They don't talk about lots of things. But they do talk about greenhouse gases in cars, that's for sure. But this would have a greater positive effect, it seems to me.
Absolutely.
Is the cost comparable? Are the economics favorable to implementation of IMO 2020?
They are for us. Yeah, we like it because we still have plenty of margin on there. The other thing that we think is a difference maker for us, we've designed all of our systems, especially the IoT, the Internet of Things, all of the devices that are on our processors have such tight cybersecurity. And we planned that several years ago. And we actually added some cybersecurity specialists for our team just to do that. And if you remember, about a year ago, 15 months ago, Maersk, the largest shipper, they were breached. In fact, they were unintentional. They were collateral damage. It was never meant for them. You actually get in and study it. But if you remember what happened when Maersk was breached, it impacted everybody. It impacted us.
Wow.
In getting, some of the chemicals we had ordered in. So we understood the impact. So you're going to see people like us spend far more time on the cybersecurity of our processing equipment.
I'm always fascinated by people who work in whatever industry it is and how many things you have to do outside of your area of expertise and things you have to bone up on and get very, very skilled at, such as cybersecurity. Has that been interesting, or has that been a challenge for you?
Well, I think it's both a challenge and an opportunity for us. We couldn't find anybody that would do IoT at the level 0, level 1, which are small devices that do everything from metering to recording.
Okay.
So they're not memory intensive. And so we actually had to develop our own processes with another group. And so now we're really moving fast ahead. We spun out a cybersecurity group that's doing extraordinarily well.
That's remarkable. Again, probably a business you never intended to start.
Not at all. But if you can't find it, it's a great opportunity.
Build it yourself, right? I mean, that's sort of the theme of what we're talking about here. You from the outside looking in, you see this opportunity. Here's where refining is, despite its many miracle accomplishments. Here's where it could be improved.
Sure.
So you do that. So, in terms of the cybersecurity that you have, here's what we need. No one's doing that. Let's build it ourselves. It's a remarkable story, Michael.
Absolutely.
It's a process you don't have. I read that you're working on this, but one thing that sort of fascinated me is being able to use the long carbons to build graphene and nanoparticle or single molecule graphene sheets. And graphene sheets that are just a molecule thick is probably one of the most fascinating materials in our future. And believe it or not, you can generate electricity just by rippling it. So graphene, a sheet of graphene, and you jiggle it, creates electricity. I'm not kidding you.
I didn't know that.
Yeah. Graphene is the future material science, just flat out statement.
No question.
Yeah, it's 10 times harder than diamonds.
Wow.
1,600 times the tensile strength of Kevlar.
Wow.
I mean, it's the amazing capabilities it has. And one of the things I like to do is write up my own kind of strategy about different things I plan to get into. And about 11 years ago, I wrote one called The Liquids of Life. And at the top of the pyramid were the three that I plan to focus on: water, blood, and oil. Is kind of the apex of the liquids of life. And graphene transcends all three of those. And what Paul was talking about, we also have patents on creating long-chain carbons that was an extension of our reformulation patent. And what's important about long-chain carbons, we have simple numbers of long-chain carbons that make petrochemicals. Your plastics, your rubbers, your simple pharmaceuticals, and those are typically under 20 long-chain carbons. We were able to construct over 25,000 long-chain carbons in this concentration. It was an unintended consequence. I would like to say it was design of experiments,
right.
But it wasn't.
Was it like a Bob Ross happy accident? The way he describes when he's painting, and he said, well, we didn't mean to put that there, but happy accident.
Oh, yeah. If I could only do his hair. But it was an outcome of we didn't power down And, one of the basic rules of a laboratory is you don't leave open flames unattended.
Right.
And that was a cardinal sin that we broke. Fortunately, it was under, all of the constraints of reformulation. We just didn't plan on running it for that additional amount of time. So it kept condensing the output. And so when we looked at it the next morning, we could smell it before we saw it. And I was so thankful that doggone place didn't, have an accident.
Sure.
And it looked like road tar on a hot summer day. It was that thick.
Wow.
And so we started to disaggregate it. We studied it. And to make a long story short, we understood that the long chains have huge potential in advanced pharmaceuticals. We've done absolutely zero on the exploratory of that, but that's where we were talking about the different phases. Phase 3 and Phase 4 is connecting with other strategic partners.
Yeah, I was just about to say, it seems to me that if you can have a feedstock, so to speak, for the creation of graphene, that might be a very good product line, but you have to have one of the very, very large companies like DuPont that have the capability to create it.
Actually, we created a sample. So being the kind of people that we are, we actually developed the software for a 3D print head, which I have in my camera. I can show you what it looks like. And so we took the long chain carbons, and we had to figure out a dilutive agent that would keep the long chain carbons intact. But like I said, you're not going to, spray that out. And you're talking about 4 angstrom, something that small, because it plugs immediately. And so we had to develop software. We had to develop the dilutive agent. And one of the things we were able to do, and again, this was one time, and it's like any other experiment, it's the repetitive nature of recreating what you did, which is important. And we were able to produce a single layer thick sheet of graphene using the 3D print head.
Wow.
Some pretty unbelievable technologies. About 3 weeks ago, we had people from Manchester, England, kind of the home of graphene, come out, and they wanted to do an exploratory. But it's all based around the beginning of the reformulation, and part of what we do is we're always trying to extend the value of the process that we created.
Sure. Well, exciting stuff, and certainly a company to watch. Michael, where can people find out more about Petrol Alchemy? I know that you don't have a large web presence, but if...
We have no web presence, but it's designed that way.
Certainly.
Best way to keep a secret is keep a secret.
But if people wanted to learn more about this, what would you recommend they do?
Get a hold of you or me or Peter.
Perfect.
Yeah.
Well, I'll tell you what. This will be on the Vital for Colorado website. That's vitalforcolorado.com. Go to the Learn tab. Go to Videos and Podcasts. You'll find this episode along with, how many have we done now, Peter? 75?
I know it's over 70.
Yeah.
And I like this show because it's another demonstration that through innovation and science, things change. Sometimes things change rapidly. And many of the product applications you described make it a better, cleaner, safer, more world. And people should embrace these kind of developments as opposed to rail against the oil and gas industry.
But we're trying to be an innovative center for Colorado with Colorado businesses, the nature of what you do.
Yeah.
And so we're the kind of living model of what that can be. And the other part, too, is we honestly believe in sharing technology, sharing knowledge, sharing the concepts that we build through this. So this is a perfect foray to be able to do that.
Well, thank you very much.
It's been an absolute pleasure getting to hear more about this. You can find Peter Moore at vitalforcolorado.com, as well as an attorney at Robinson, Waters, and Odorcio. Thank you for listening. It's been a real pleasure, Michael. Have a wonderful day.
Thanks a lot, John.
Thanks, John.